Number 5 is a half-life question. So we want to write the equation for the amount of radioactive substance with a half-life of 30 days. If 10 grams are present when t equals 0, we want to find the remaining amount after 40 days. So we know that we start off with 10 grams, and we're going to use the equation y equals ae to the bx. So we start off with 10 grams. And we don't know the rate of decay yet, but we do know that after 30 days, we have half the amount left, and half the amount of 10 is 5. So this will help us solve for the rate of decay. So if we divide by 10, we know that 1/2 equals e to the 30b. And if we take the natural log of 1/2, we have that equals 30b. So if we divide by 30, we will know our decay rate. So we get that B equals -0.023. Now that we know the decay rate, we can just plug it into our formula to know how much we'll have of the substance after 40 days. So we have y equals 10 times e to the -0.023 times 40, which equals 3.985. grams. For number 6, we want to know the level of sound when the intensity is 10 to the -15. So we're going to plug that in. So we have 10 times log base 10 of 10 to the -15 over 10 to the -16. And we can flip that fraction around since both of the exponents are negative. So we'll flip it over as 10 to the 16th over 10 to the 15th, which is really just 10. So we have 10 times log base 10 of 10. Log base 10 of 10 equals 1, so 10 times 1 is 10. So the answer is actually none of these, since the decibel level would be 10. For the very last problem, we would like to find the pH of a solution where H equals 7.61 times 10 to the -6. So all we need to do is plug that into our equations. So we have negative log base 10 of 7.61 times 10 to the -6. And if we plug that into our calculator, we get 5.12. And it is positive, so make sure we have that as a positive answer. So the answer is C.